Okay, thank you, Eric, for the presentation. Yes, my name is Nicolas Waern. I'm also having Daniel Raza here, who's my head of AI. So I'm the founder of Life Atlas and also Winniio, which you can see here. And today I'm going to present what we've done with EdgeLake, AnyLog as a foundation regarding self-learning smart heating digital twins. Not so much that, but I'm going to go into what we started with, and then how this has evolved into quantum-safe, decentralized health journals at the edge, which is what Eric said, smart homes, but feeding that data into decentralized health journals. So creating decentralized intelligent ecosystems, that's what we've been, I would say, trying to do for a while. I've got a background in innovation and strategy, worked with smart buildings, well, dumb buildings, trying to make them smart for the last 8 to 10 years. So always with an edge native approach. We were one of the first ones with a company called GoIT that had a edge native approach, a Raspberry Pi controller. One of the first ones actually with IBM Watson tied to BACnet, which is a building automation protocol. We use BACnet web services, so we can get one API from a building and, well, to and from a building, and making that intelligent as well. We've implemented this in smart buildings, and if everyone is familiar with the situation in Ukraine, we could see that energy systems need to be more resilient, need to be self-learning, not necessarily cloud dependent, so that data is being processed somewhere else. And that's what we and I created about, what is it, 5 years ago, implemented that into 3 schools in Sweden. And the idea was to create self-learning, platform-independent smart heating systems that could go into any facility, learn what is going on at the edge, and commandeer the, in this case, actuators for heating to optimally find its own way without any intervention from humans, based on goals set, well, by humans, but also by different standards. So we made this work, and what you see here is also a visualization slash physics-based environment based on Unreal Engine. So we had basically the whole shebang: edge native hardware, wireless mesh sensors, all of this talking in concert and actually actuating the building from the future. And well, this is a little bit what it looked like. We use this as a knowledge transfer between new developers, the people that we're working with in terms of energy optimization, the building owner, the principal, to create a shared reality, because otherwise everyone was looking at the same school through different lenses. We could tie in real-time data, could see what has happened, what was happening, and what would happen as well. The visualization was extremely important to understand when the sun was rising from the east and how that affected the right wing, when the sun traveled, well, across the building, and how it affected different rooms. Because earlier, when we didn't have the visualization in the beginning of the project, we could not necessarily figure out why these things were happening. Once we had the sun, showing this, it was a lot easier. What this has evolved in is not just smart buildings, but trying to make this into smart humans and providing a decentralized environment where people can control, collect all the data in one place, and actually store it in a smart home hub, and still getting data from the smart home or the building, but having that in a decentralized edge lake, so we can share insights and federated learnings, not necessarily data. So that's what I'm going to talk about a little bit. And the reason why is that in the US alone, life expectancy, unfortunately, has gone down for a lot of different reasons. And 30-year-olds, and I'm quite a lot older than that, but they seem to have more than one chronic disease, meaning that they will be in pain for 47 years. Poor data quality, sorry, rate from fragmented healthcare system. Maybe that's a little bit loaded, and it doesn't necessarily mean the US only, but it spells disaster for personal health, again, because we're not necessarily in control of our own data. So what I believe, and many with me believe, is that we need more modern tools and business models to deliver insight in days instead of years, and for that insights to be shared with others in the network at the speed of latency. And again, just a little bit more why this is needed. AI will, maybe, who knows, now when there's an AI bubble, but will be 100 times more intelligent than it is right now. And in terms of healthcare, it's really it's not really a high likelihood that existing healthcare system will make people healthier for a lot of different reasons. It's extremely fragmented. We don't have the delivery models, and we need to get more holistic data for clinical trials, drug development. It takes 13, 15 years today based on synthetic data or very fragmented data. And what we want to do and what we're doing is, again, collecting this data in one place, sharing insights, federated learning with the world. And if you look at China, what they've done, this is quite old right now. It's in May 30, 2024. And this is actually based on Stanford research as well with multi-agent agentic systems. Well, AI agents that works in a simulated environment, simulacrums, not necessarily AI agent-based models and multi-agentic systems. So what they've done is that you can take a health journal, send it into a digital hospital, go through 10,000 simulations in a couple of hours. That would otherwise take a couple of years. And we believe that this is needed as well, but not necessarily from a government perspective, but from a decentralized perspective where people can help other people in a global ecosystem. And we're seeing, again, the need for edgelake and sovereignty when it comes to chat control. So if you don't know what chat control is, and maybe you're not in Europe, I'm not really sure exactly how this is in the US, but it's basically government initiatives where governments, pull together to make sure that you can spy on more or less anything and everything. I think like the origin idea was pretty good when it comes to fighting child pornography and these kind of things, but to be able to spy on every piece of information that is being shared privately with everyone else, it doesn't necessarily, become that great in the future. So the Life Atlas model, again, is based on edgelake and the idea of decentralized systems that are well connected together. So citizens, people run quantum safe edge nodes. We built it in a way so that if you look at IKEA's technology when it comes to wireless mesh sensoring, it's exactly the same stuff that we have incorporated in our platform. And that could turn them into personal data centers, which again, now with edge compute from a lot of different players, is definitely possible. And everyone's going to have a data center in their home anyway. Well, a little bit more about this, fragmentation. We saw this early on when it came to our segment. One of the early people that, went into this was, well, how this started was that my family member of mine, she got breast cancer and she had all the data in different places. The doctors couldn't really understand what was going on because they didn't really know that she was still taking medicine from her heart. So what happened was that she was prescribed, well, the right medicine for the cancer, but that conflicting with the existing medicine, it was a really big problem. And this is what I've been seeing for the last, I would say, 10 years, again, working with international management, IT management, industrial automation, that you try to optimize something, but because you don't have a holistic perspective, you actually, not optimizing the entire network and you're making it sub-optimized. So this was exactly the case with with a family member, but also a friend of mine who played in the NHL in the US. He came back to Sweden with 14 years worth of data, or sorry, without 14 years worth of data, and complained that he has problems with his neck. And he saw different specialists. It's actually not 11. That was an exaggeration. It was 5, 6 specialists. All of them missed what it was. He got desperate, saw the last specialist, had a picture of an MRI, and he quickly saw, oh, well, you got this type of neck, so all the stuff that you've been doing, doesn't really work. And if he'd had all this information, combined that with wearable data, made this safe and secure, he could then use AI, invite to innovate from doctors all over the world, have AI agents use this, and basically be in control of his past, present, and simulate the future. So this is what we have been developing. And again, it's based on exactly, I would say, the same architecture as we did for buildings, but also layering in health data. So not just wireless mesh data from sensors in the building or in my home or in people's homes, but also wearable data from Oura Ring, Strava, and sending that to both the cloud environment and also having that mirrored in the edge and vice versa. So the system architecture, maybe this is why all of you are here. This was the old one, I would say, before we got into EdgeLake. We still had an edge native approach, microservices, taxonomies, ontology handlers at the edge, feeding in real-time data from CO2 sensors, temperature, humidity, occupancy, and also actuators. So it's a bi-directional control where you had AI at the edge. This was learning continuously through random forest decision trees and incremental learning, what would happen in the building, and then controlling the entire building from the future. REST interface to mobile apps. This should probably be GraphQL, Kafka services, microservices, and Grafana visualization, again, game engine as well. So the idea with this was, again, edge native by design, but it needed to be more resilient, and it needed to be sending not just data, but federated learning as well. So the outcome for buildings when we had this in play was predictive, prescriptive, secure, and adaptive. And this was interesting and important because existing real estate today comprises of 40% of the total energy consumption. Most of the solution that is in the smart building territory, they're cloud only. So if connectivity goes down, which is done now again in Ukraine, and we see more focus on AI Act, resiliency, and SA1 and SS2 here in Sweden and Europe, where it's more information about critical infrastructure. And here we could see that the building would learn itself. So here's the prediction in the top one, and the predictions are exactly the same, more or less, of what actually happened. And the self-learning aspect is that it goes in, it's trying to fine-tune, and then finds its own way of the desired goal temperature. And the system architecture after Life Atlas, after EdgeLake and AnyLog, was that we can have, and I think Danielle, if you want to step in, please do so, which was more that we can scale this up. It was similar for site to site to site. We could scale this much more, and they were also connected edge to edge. So we could see a completely, I would say, more scalable architecture. Again, not just sending data, but the intent of sending also federated learning perspectives. What we didn't have, which is what we've gone right now, is the security aspects, and we actually didn't really implement the real federated learning, which we have right now as well. So
And I think one more small
please.
couple of things to add here were so in the previous architecture, the old one that you saw, one of the major problems was definitely scaling and also keeping the data uh, in within the building due to data policies or security policies, right? And with EdgeLake and AnyLog, we were able to scale a lot better and also keep the data of the building within the edge for better access and also from security purposes. And if and when needed, we could also move it to the cloud, but not the data itself, using the federated learning concept, that the information in an anonymized format that goes out, but the actual data, the identifiers stay within the building.
Exactly. And I think what we move towards now, again, is both quantum safe communication, also what Daniel said, federated learning, and incorporating also, health models, DNA records, blood work, all this kind of stuff, Aura rings, Strava feeds into the edge gateway. So it acts as a smart, secure home hub. And it's the same architecture backbone that we had before, but it can be applied into this perspective, which is, in my opinion, more or less future-proof. Because the boxes or the chipsets, we have the TPUs, the MPUs, the CPUs, the GPUs, a lot of all these kind of PUs. And I think in the future, it's going to be also intent-driven. We're going to have much, much more AI on the edge. This is the way to go. We see this as well with sovereign AI. And today we have something that is more quantum safe thanks to Patero. So they're helping out to create a quantum safe communication layer on top of or inside of EdgeLake and the Winniio Cloud, Winniio Edge, which is a life atlas application here. And in the future, we also see that it's not only going to be quantum safe by design, but probably quantum, enabled, because HPC, high performance compute plus quantum means more precision. And I think that's exactly what is happening today in the space of genetics, epigenetics, digital twins of people, where you have so much more data that you want to go through, but you're limited by the compute power or the architecture that we have. Yeah, the outcomes for people is exactly what, very much the same for building owners. So building owners, they own their own buildings. They generate a lot of data that they today can't really take care of. It's the same with people. We are possibly owners of our own bodies, but the data that we generate is stuck in different systems. So by doing this, and you can see the video here, we'll be able to display what has happened, when it happened, on the body, on when it happened, also in you have a visual timeline of when something happened. You can complement that with mood, and also have traditional timeline summary of when it happened as well. So this increases health literacy and portability. If you're traveling, you have all your data with you. You can send your digital twin data to any clinic beforehand. And it's very much the same as it becomes predictive, prescriptive, secure, and adaptive. And in this case, it's based on EdgeLake Foundation here on the smart home, and then hardened by quantum safe, self-learning, self-prescribing recommendations based on the goals that people would have. So that was probably a little bit faster, but yeah. And thank you for the attention.
Thank you, Nicola. And so I actually have a question for you.
Yeah.
Do you think this is going to be like very appropriate for people who have, those kind of long-term illnesses like diabetes and this kind of specific, kind of users, or is this something you think is will be attractive to regular people?
Both. I think this is what everyone will have in their home. Of course, I have to say that because I'm a founder that believes in the vision, right? But no. We onboarding diabetes people, cancer survivors, a lot of these people, and I think the interesting part when it comes to the application of decentralized ecosystems is the ones with chronic diseases, and especially rare and chronic diseases, because they can then pull their data together or the insights together so that researchers actually have a fighting chance, and you add more context to the data so it's much richer. And by sharing these insights in graphs that are anonymized by design, you can then query populations versus just collecting data that is very fragmented and non-descriptive. So we're onboarding people that have Hashimoto's disease, because again, the data that exists in the research community is not necessarily enough. It doesn't have enough context. So the answer is definitely diabetes is extremely interesting. I talked to someone earlier, what was it, yesterday, that said that this is really needed. They had what is it, a patch which helps wounds heal faster, because with diabetes, that's actually a really big problem. And she said that they want to be able to share this data from a connected patch to basically more holistic network, and also receive more information so they can see, okay, which different humans, what kind of skin types would this actually work better for. And this is also the same when you talk to ANSYS, which do simulations. So they could get asked by a pharma company and say, okay, we want to develop a molecular device, or we want to try these drugs out. And today it's becoming more and more synthetic data, synthetic control arms before you go to first in human trials and do this drug discovery. So no. This is definitely a must for pharma companies that today depend a lot on synthetic data, which is again is not real. Here we can share anonymized, richer, contextualized information, which in turn would lead to precision recommendations and precision medicine in the future, and also better and faster drug discovery, because you're actually having real data from humans, which hasn't necessarily been existing before. So we're seeing a lot of interest actually, and definitely for diabetes, chronic diseases, but also for regular Joes, like Joe Pearson, maybe. And especially we see in that the Ironman professionals, endurance athletes. We're now talking to the ones who want to climb Mount Everest in 3 years. And they want to say, okay, I want to climb Mount Everest in 3 years, optimize my, performance until then. So they, feeding wearable data, what they eat, what they see, sleep, and just to fine tune and create a baseline and AI model for themselves, basically. And maybe Joe is not a regular, obviously he's here. So, but this is this is really what we're seeing. So yeah, any questions, any comments?
Questions?
So is your approach, let's say for Life Atlas specifically, is it around a specific machine in the home? That would be this hub of information. That's the canonical source of the local personal sovereign data that would also need to be backed up in some way, just in case, because it's a single point of failure. And that then the individual can choose what data is shared with what people or providers or companies, and does it need to be anonymized or otherwise have the identity obscured while providing the pure signal, the pure data to the various providers. And a person may actually be compensated for it, hypothetically, or they can give it away for free. Okay, we are already working on something similar, but in a completely different area, with agriculture on small family farms in Germany.
Okay. Yeah, I was in smallholder farming 12 years ago, basically in Nigeria.
Okay, excellent. Yeah, so the platform that we use in Germany is called the Hofbox. And it's a small fanless x86 machine that is able to dynamically deploy and upgrade and remove containerized workloads and machine learning.
Yeah.
And one of the pieces that we're missing right now are the data transport, which edgelake can provide, as well as the federated learning aspect, which we are partnering with edgelake to implement their solutions. So it's really interesting how your scenario is similar, but in a different field. Also, in Germany, they're worried about, data sovereignty and data privacy. However, I believe health records need an additional layer of encryption security. That's why you mentioned quantum safe.
It's also zero proofs, right? So, I mean, you're absolutely spot on. I mean, like the architecture for this, in my opinion, will be the same for almost anything. Right? It doesn't matter if it's culture, and exactly what you're saying with being rewarded, because that's what's if I go back like 3 years, because I'm part of the digital twin consortium in the US, so we talked to pharma companies. Pharma companies were paying for really crappy data already, right? So one of the, I think, biggest one, what I don't know, can't remember what they call, Point Click Care, is a healthcare provider for elderly homes. So they sell the data about the elderly, and of course they're not compensating the ones that actually providing the data, right? So they're selling the data to big pharma, making quite a lot of money, but the data is really bad. It's non-contextual, it's really unspecific. It provides some kind of patterns. So that was like one of the first ideas. Okay, what if you have phenomenal data, rich data, contextual information, and can actually share this anonymous ways and reward the people, right? To create a passive income just by sharing your information. So this is more or less validated right now in the discussions with ANSYS, because they get paid also quite a lot of money from big pharma companies to run synthetic cohorts. But again, it's based on really bad data. So the idea here is that if you have better, richer data, you can charge more, but then you can also create a reward back to the people that actually shared it. So spot on, definitely. And I would love to hear more about the use case with agriculture. Again, I've been working in that space for, on and off for 12 years as well. So IoT is IoT. So
I have a question for you. I know you've put a setup together with Daniel
Yeah.
What is the device size for that type of application? And kind of the target price you think this would cost? And then who's going to buy this? I guess from what you said, this is going to be, who's your client? Is it the end guy, the Joe, or is this like, I don't know, medical insurance company?
Yeah, it's a really good question. I think like right now we're seeing a lot of interest. Buying signals this week has been from actually founders that, want to have this, maybe have smart home aspects, looking into this and longevity. And that's also what we started with. We're also seeing interest from labs. It's not necessarily, it's the same architecture, not necessarily the same application. What I see in the future, though, is yeah, everyone's going to have it, but it starts with the ones that have these problems. So again, the chronic diseases, cancer, the ones that need to have better control, being able to visualize this in a timeline, and also wants to, make it private and secure. And the price is going down, I would say, like every day. Right now, we have the one that we had before, we implemented that in an Intel Nuke box. We have this one, which is an NVIDIA, which one is this? Jetson Orin, I think. And what we're seeing is that it doesn't have to be that costly. Again, we've made it so with the wireless sensoring that you can buy, something from IKEA to get this stuff in, and then do an install most likely in the future as well. So we're a startup scale up. We haven't necessarily figured out the business model yet and what the ideal customer ICP customer profile is. But that's sort of the ones that have shown interest, starting to pay. We have the cloud subscription, which is Aura data, Strava data coming into a secure location only in the cloud. And then if they want to harden it, that's where, again, they can buy a box, right? So that's a little bit where we are, if that's,
And
answers the question.
have you thought about using the boxes that are already at the clients, like
What did you
those,
say? Have we tried to?
most of the Joes, they have a TV.
Mm-hmm.
They watch TV through their fiber, so they all have a modem, and this has some compute capacity, whether it's typically provided by an operator, like
Yeah.
Orange in Europe, or can be Vodafone or the others. Have you looked into, instead of having a device, using an existing device that's already in the home?
Mm-hmm. Mm-hmm. Yeah. I mean, yes and no. Thought about it, yes. Looked into it, not that much. I was attending both Mobile World Congress, not this year, but last year, and also some event in Amsterdam, like 2 years ago. I talked to these top box companies, and they wanted to deliver more services. I was also I was speaking at the Future of Stadiums event. What was this? Well, a couple of months ago in the UK. So Arsenal was there and this, Premier League clubs, and they wanted to say, okay, how do we attract more customers, or, how do we get brand loyalty? And one of the ideas was exactly what you're saying, that you provide better, more services to people's homes, and you can bundle that in with different types of information. But no, yes, I think it's a phenomenal idea. The closest one has been this IKEA play that we're using exactly the same wireless mesh technology since my smart building days, and that it could be just an install into a box, into an orchestrator that you have in your home, but you harden it with the quantum safe communication. That's why, Patero is here. It can be complemented with Life Atlas, so providing also a secure, safe space for all your health data. So yes, in terms of IKEA smart home tech, not necessarily the internet top boxes or these kind of things, but it's a great suggestion.
Nicolas, it's very intriguing. From a big picture, I worry about security, and I know you've kind of addressed that. From a big picture, how do I allow my data to go into the analysis? That's my biggest question, but I think the premise is pretty good as long as I opt into it, right?
Exactly. No, I think that's the whole point, that you can opt in, both with sort of raw data if you want anyone to see that. But working with a company here in Sweden called Dipella, That's again like the idea with zero knowledge proofs, also federated learning, that you're sending insights to someone, or AI agents or these, digital hospitals, so that you're not necessarily working with the raw data. So that's the whole idea, that you could have AI agents, doctors working together for the first time because they see the whole picture, but they don't necessarily know anything about you, right? You have the data, they have representations, but they don't know anything about you, right? And I think one of the advisors that we have, he was, in one of the big insurance companies in the US, and they had access to 230 million Americans at one point in time, and be able to see in real time, more or less, when people visited clinics, and what to do and what not to do. And one of the early points in when they built this massive graph database in Tychograph, was that the data, as a person, as a patient, or as someone with data, they made a mistake. Maybe I shouldn't say this, but they made a little bit of mistake there in the beginning before they went live, in the sense that you couldn't really control the data sources, from a granular level. They fixed that with the nodes, so that you can really opt in and opt out on an extremely granular level, to be able to see what someone would be able to see, shouldn't see, and all this kind of stuff. But still having researchers and AI having access to that data, to being able to draw insights, because otherwise you're creating insights in a vacuum, because you need access to the data, right? So I think that's where it's really interesting now, the developments when it comes to hardware root of trust, zero knowledge proofs, again, federated learning, not necessarily European data spaces, but more, again, these knowledge insight spaces where you're, again, are able to share this insights or results, and you can pull this together to find out more stuff, but you can't necessarily reverse engineer it back to the person, right? So you're getting all the benefits, but without the risk.
Have you guys run federated learning or trained models successfully in production using federated learning?
So unfortunately, the smart building aspects has been, it's now in hiatus because they were doing renovations. So that's also why, we actually implemented in my home. So we did run this successfully in production. We did that with global models. So we had the 38 rooms, I think, in one of the schools, and each and every room were then contributing to the global model, which sat in the edge gateway. And I remember we had it in production because someone, we were worried. I mean, no one knew that we were doing this, right? But with global poisoning and all this kind of stuff. So yes, fairly successfully, we had it successfully working. In the smart home right now, it's such a small, it's not really a big setup. So we have this working, if you want to call it production or not, I'm not really sure. But I can't really answer to any technical questions, unfortunately. But I remember our, discussion, I think it was last year, where we already tried this before EdgeLake came into the play, right? Or came into play. But we see EdgeLake as well as AnyLog, we don't have to do the heavy lifting. It's got the templates. It's much, much easier for us to implement this, again, at scale, right? So
yeah. One thing from the last years, we also built out a framework that fully facilitates federated learning. So the framework allows you to just write your machine learning application, so the training rules, the inference endpoints. And then EdgeLake actually facilitates the model, sending the models to the aggregator, aggregation, and moving all the models around to do training successfully.
Perfect. Yeah, I'm pretty confident, and I can say that confidently now when Daniel is not here, that we have this up and running. Because again, I remember our conversation when you didn't have it, and I think that we have implemented it as well. Also in this smaller setup that we have here. And I mean, it's really, for me, being at the cutting edge is a lot of fun because you can see everything is sort of moving in from cloud. You see cloud exits to edge native ways of working. And I'm guessing you're also seeing this, right? So, it's really interesting. And again, also with this quantum PQC, post-quantum computing, paradigm shift that is happening in Q-Day. And I've been looking forward more to not just quantum safe, but quantum acceleration when you have all this data. And again, we're seeing this is a big problem with labs, that you're generating so much more information, but you're still stuck in the way how you've been operating in different silos. And now you actually need, this EdgeLake, AnyLog. You need to scale. You need to do this across labs. You need to do it in a secure way. It is very, very interesting, actually.
Yeah, it's interesting you pull in the quantum stuff. So I agree, and I think you're on the right track, at least with personal PHI. I agree with PHI. I mean, I think quantum makes a lot of sense with PHI.
And PHI, personal health information, or is that something else?
Yeah, PHI, yeah, personal health information.
Okay, yeah.
Yeah. I'm sorry. I'm an American and I use acronyms.
No, of course, of course, of course. No, I think like speaking of acronyms, like IPS, like International Patient Summary, you have, of course, Digital Product Pass. You have all these things that are, converging. I wouldn't say right now, Digital Product Pass has been existing, for 5 to 10 years, but that in industrial sense is very similar to what, people are trying to achieve now with international patient summaries, so that you can travel across borders, again, but have your information with you and that it's standardized. You have taxonomies and ontologies in the healthcare space that are trying to fit this into different boxes. I think that that's a little bit of a myopic way of looking at it, because you usually can't really add context. It's not necessarily dynamic. It's not necessarily editable. You can't reward people for sharing their information. It's very limited to health or sickness, not all the other data that life is all about. So with this way of working, again, you get access to rich, holistic, dynamic, real-time context, as well as deeper personalized information that they can then be shared. So it's sort of trying to compete with a very rigid and static data collection world versus then decentralized real-time data where you share insights instead of data, right? So it's just I would say like it's fun, interesting, and tormenting, at the same time, because it's not that easy. But I definitely think it's needed, and it is the future. Absolutely.